Hi everyone, welcome back to our channel. Today we are going to see the continuation of the previous year question paper problem. Let's enter into the problem. If A is the given matrix, then find A inverse and use it to solve the following system of the equations. Here the system of equation is in the form Ax equals to B, where x is equals to x, y, z, and B matrix is nothing but the given value. B is equals to 6, 3, 2. So here I have to, using this following system of equations, I have to calculate the values of x, y, z. So that I am keeping x as it is and taking A to the other side, so that I have A inverse B. Now I have the values for B matrix. I want to calculate the value A inverse. So for that I am entering into the solution part. Write solution and write the A matrix. A is equals to 1, 2, minus 3. First row. Then second row is 3, 2, minus 2. And then third row is 2, minus 1 and 1. We know the formula for A inverse. A inverse is nothing but 1 by modulus of A into adjoint of A. So in order to find the value of A inverse, first I have to calculate what is adjoint of A and what is modulus of A. First, modulus of A, which is equals to, write the matrix symbols plus, minus, plus, and here for column plus, minus and plus. Okay, don't put the symbol inside the matrix, put it in the outside, so that we can't get confused. Okay, so first leaving the first row and first column, writing the remaining term as follows: 2, minus 2 and minus 1, 1. Next, leaving the first row and the second column, the remaining term is 3, minus 2 and 2, 1. Next one is leaving the third column and the first row, the remaining term is 3, 2, 2, minus 1. On calculating these, we can get the value for modulus of A. So 1 into 2 minus of plus 2, which minus 2 into 3 plus 4. The third term is minus 3 into minus 3 minus 4, which is equals to 1 into 2 minus 2 is nothing but 0. First term is 0. The second term is 2 into 7 and third term is 3 into minus 7, which is equals to 0, minus 14 and plus 21, which is equals to 7. So that I am getting the value for modulus of A. Then adjoint of A. Adjoint of A equal to cofactor of A transpose. So if we find cofactor, then we can easily find out the adjoint of A by reversing the row and columns. So cofactor of A is, we have to find the each and every entries of the matrix, which is A11, A12, A13 and 21, 23, A23 and A31, etc. So first write the symbols outside: plus, minus, plus, minus, plus and minus. So the matrix value is, first A11 is leaving the first row and first column, write the remaining values. 2 remaining entries, 2 minus 2 minus 1, 1, which is equals to 2 minus 2. It is 0. And next is leaving the first row and second column, because A12. So leaving the first row and second column, the remaining entries 3 minus 2 and 2, 1, which is equals to minus of 3 into 3 plus 4. So I have minus 7. Next entry is A13. A13 is leaving the first row and third column. The remaining factor is 3, 2, 2, minus 1, which is equals to minus 3 and minus 4. So equal to minus 7. Next value is A21. So leaving the second row and first column. So 2 minus 3 and minus 1 plus 1, which is equals to minus of 2 minus of minus plus 3, again minus 3, equal to plus 1. Next value is A22. So that I am leaving second row and second column. The remaining term is, leaving the second row and second column, I have 1 minus 3 and 2 1, which is equals to 1 minus of minus plus 6 equal to 7. Next one is A23. A23 is leaving the second row and third column. I have 1 2 2 minus 1. 1 2 2 minus 1, which is equal to minus of minus 1 minus 4, which is equal to plus 5. Next we have to calculate the remaining entries. A31, A32, A33, and put the symbol outside. Plus, here last I finished in minus, so plus minus plus. Okay, the next value is A31. Leaving the third row and first column, the remaining entry is 2 minus 3 and 2 minus 2. So the answer is minus 4 plus 6 equal to 2. Next A32. A32 is leaving the third row and second column. So that I have 1 minus 3 and third row and second column. 1 minus 3, 3 minus 2. So minus 2 plus 9 equal to 7. Next, the A33. A3 is leaving the third row and third column. The remaining factor is 1, 2, 3, 2. So the answer is minus 4. Now, writing the cofactor entries here. Cofactor of A. Cofactor of A is matrix of A11, A12, A13, A21, A22, A23. Third row is 31, A31, A32 and A33. So the value is A11 is 0 and A12 is minus 7, A13 is minus 7 and A21 is 1, A22 is 7 and 33 is 5, A31 is 2 and minus 7 and minus 4. So now I have cofactor of A. I am taking the transpose of cofactor of A, which is nothing but reversing row into column and column into row, which is nothing but adjoint of A. I already told in the. Okay, next cofactor of A transpose equal to adjoint of A. Adjoint of A equal to 0, 1, 2. Write the entries in the row. Minus 7, 7, minus 7. Next, third row will become third column. Third column will become third row. Minus 7, 5, minus 4. So now I have both the values, modulus of A and adjoint of A. So A inverse equal to 1 by 7 into adjoint of A. 0, 1, 2, minus 7, 7, 5. Minus 7 minus 4. Now I can calculate x. X is equal to A inverse into B. So x, y, z matrix here, matrix value x, y, z. A inverse is 1 by 7. Matrix value 0, minus 7, minus 7, 7, 5, minus 7, minus 4. So B value is 6, 3, 2. On solving this, we will get the values for x, y and z. Here the first matrix is 3 cross 3 matrix, 3 rows and 3 columns. Second matrix is 3 cross 1. My answer will be in 3 cross 1 matrix, which is 3 rows and 1 column. 1 by 7 multiplying the first row into first column. So 6 zeros are 0 plus 3 ones are 3, 2 twos are 4. Next, second row and first column, minus 42 plus 21 minus 14. Next, minus 42 plus 15 minus 8, which is equals to 1 by 7. On adding all those things, we get the first value as 7 and the second value is minus 42 plus 21 is minus 21, minus 21 minus 14 is minus 35. Third value is minus 42 plus 15 is minus 50 minus 15 is minus 35, okay, which is equals to taking 1 by 7 inside the matrix. 1 by 7 into 7 is 1. And the next value is 1 by 7 into minus 35 is minus 5, 1 by 7 into minus 35 is minus 5. So, I got the value for x, y and z, which implies x is equal to 1 and y is equals to minus 5 and z equal to minus 5. Hence the solution. Thank you. Thanks for watching.